All right, hello once again. Jeff Scott of Rankin Technical College. We've been going over MySQL by examples for beginners at the URL that's shown right here. We did not directly go over the summary of MySQL commands, but we've gone over now all of section 2, where we created an example database called products. We saw how to create and delete a database, how to set our default database with the use command, how to create and delete tables, how to insert rows with the insert into, how to query a database using the select statement, how to produce summary reports, in which we also talked about the aggregate commands, those being sum, min, max, avg, and count star. We talked about modifying data using the update command, deleting data using the delete command. We had a lot of problems with the loading and exporting, but I did show you a little bit on running a script. Rather than jumping into part 3, which is working with more than one table, which we will do, I instead want to go through part 4 first, where we talk about primary keys, foreign keys, and indexes. This may take one lecture, it may take 2. I'm not sure. Then after this, we will go and jump back into part 3, where we'll talk about table relationships, one-to-many, many-to-many, and one-to-one relationships. We'll quickly look at the backup and restore capabilities, and then we'll jump into, I might even just skip this for now and might jump right into more on join. So we're going to do basically 2, then 4, then 3, then 6, then we'll come back and do 5 and 7. So we will hit all of it, just not exactly in the order that it's shown. All right, so I'm up to, if you are following along with a hard copy of this, it's about 44 pages. And if I jump up here now, I am about, I think it was around page, I'm going to say 25. Right here. And it looks like it is page 25. More on primary key, foreign key, and index. So that's what I want to talk about with you right now. Somehow I jumped backwards, but that's okay. We'll find right where we were. There we go. So, as mentioned here, under the primary key. Now, I define a primary key, my definition, okay? This is Jeff's definition. I've given you a bunch of definitions in here before. RDBMS, which is a relational database management system. I defined a database. I defined a table. I defined a record. I defined a field. I defined a character. I defined data. And I defined information. So let's move down a little bit. And now let's talk about a primary key. And I'm going to give a very simple definition of a primary key. I'm going to say that a primary key is a unique record identifier. And I'll put a little message here. Should be what's known as unintelligible. I think I'm spelling that correctly. But I want to look at what all of that means right now. Okay? Let's look at it in the guise of here, this. This is our primary key. What that means is, if I come through here and I try to say insert into products 2 values, and I'm going to try to manually, I shouldn't do this, but I'm going to put purposely 2001, which is already being used, PEC, pencil, we'll call it ZZ. This isn't going to work anyway. The quantity 1,000, the price 0.50. Now this should not work. Duplicate entry for key primary. I've already got a primary key of 2001, so I cannot create another record with that same key, because each must be unique, because a primary key indeed is a unique record identifier. That's pretty much what they say in here. If the primary key is a single field, they're calling it a simple key. If the primary key consists of more than one field, it's typically called a combined primary key or a composite primary key. We're going to get into that when we jump back into section 3. All right. Now, the other thing that's not in here that I put in was the fact that, let's see, I can keep that. All right. The other thing that I put into here was the fact that it should be unintelligible. What does that mean? That means that, for example, you should not use a field like Social Security number for a primary key. Everyone's Social Security number is supposed to be unique, but the Social Security number field is intelligible. It's not unintelligible, it is intelligible. What that means is if somebody gets a hold of your Social Security number as your primary key, they can find out a lot of information about you. On the other hand, if somebody gets a hold of the fact that your product ID is 2001, there's not really all that much they can do about that or with that. All right? Then we talk about a foreign key. Now, I'm going to give you an example, and I'm just going to literally do it in here. So in other words, I'm going to go in and I'm going to do it. I can close this, I can close this. Let's bring this one up. Okay? Let's suppose that I have two tables. I have a table here that's called employees. So this is my first table, employees. And the employees table has these fields: first name, last name, address, city, state, zip, and let's say cell phone. All right? Now, there's no field in there that really could be used as a primary key, so I'll create one, and I'll just call it employee ID. Okay? Now, I've got another table in here, and that table is called departments, very similar to the table we looked at before that we have in a, that we'll have in a later database. That will have a department ID, and it'll have a department name. Okay? So this field right here, employee ID, I'm just going to put an asterisk there. That's our primary key, and that's our primary key. All right? Hopefully, when you look at these, you would agree that there are no fields in common between the two tables. There are no fields in common between these two tables. So if somebody says, okay, I want a list of the first name, last name, and department name of every employee, as of right now, there is no way to do that. Okay? So we have to look at it. We have to say, okay, departments. Do departments contain employees, or do employees contain departments? Well, you'd think that's a silly question because departments contain employees. So every department has 0, 1, or more employees in it. That should make sense to you. So in other words, if we had a relationship between these two tables, for lack of better words, it would be a parent-child relationship. So this would be the parent, and this would be the child. All right? So there's different ways that we can do this, but what I would do in this case is I would come into my employees table, and I would add department ID in there as another field, because now I can relate this table with this table. Now this particular field is not a primary key in this table. This is a primary key in this table. So what I've done is I have added the primary key of my parent table into my child table. So I'm able to relate these two tables together. Doing that, I'm going to put 2 asterisks here. If I've got a single asterisk, that means primary key. If I have 2 asterisks, that means what's called a foreign key. So the only reason that I added this field into this table was so that I could relate these 2 tables together. That's the concept or the idea behind a foreign key. Now that's my explanation. So let's go in and take a look at what the author says here. The author says that a foreign key of a child table is used to reference the parent table. The foreign key constraint can be imposed to ensure referential integrity. What that means is you never have what are called orphan records. Now, if that confuses you, let's go back to what we just did. Every employee should have a department associated with him or her. All right? And we're able to do that because of the foreign key relationship between this table and this table. We define the foreign key when we define the child table. So the parent table should be defined first, then the child table. And what we say here is, what do we want to have happen if we remove the parent? If we remove the parent, all right, if we remove the parent and we want the children to be removed also, we can tell it to cascade. So when we either update the parent, all right, this literally says with cascade delete or cascade update, it says if we delete a parent, delete all the child records. If we update a parent, update all the child records. So we can choose cascade to do that. We can choose restrict, which is the default, which does not allow a parent to be deleted or updated, is if that parent has matching children. If the parent has any children, you can't remove the parent, you can't change the parent. You can set it equal to null, so that if you do change the parent, the associated child record or records are set to null. You can do no action, which, as it says, it's the same as restrict. All right? So if we came in here and did this, and I think they're saying here, we're going to have a brand new we're going to create a brand new table. Okay? And that brand new table is going to be products suppliers. And it's going to have a product ID, and it's going to have a supplier ID. What this means is, okay, supplier 501 supplies products 2001, 2002, and 2003. Supplier 502 supplies product 204, and supplier 503, like supplier 501, also supplies product 2001. So what the author says, that if you want to do this, and if I say delete from suppliers where supplier ID equals 501, in this case, you're going to get an error message. All right? So that might be a little confusing. So let's look at the example that I gave, which hopefully you think at least is a little easier to understand. All right? So you saw the examples here. I'm going to cut the size of this way down. I'm going to cut it down to about half of its current size. Okay? So let's assume that I have these records. So for employees, again, I'm making all this up literally off the top of my head. I'm going to have employee ID 1001, and it'll be Jeff Scott 755. I'll put a comma in between each one of these rows so you can, or these fields, so you can see what goes with what. So that will be 755 Parr Road, Wentzville, Missouri, 63385. All right, I'm just going to quickly add, I'm going to put 3 employees in here. And I'm just going to make them members of my family. All right, and we're going to say that we all live right there. Okay, so that's that. And then in our departments table, we'll say that Department 1 is IT, that Department 2 is shipping, and that Department 3 is receiving. All right? So we put all this city, state, zip. We need a phone number. And for ease of use, I'm just going to give everybody my phone number. All right. And we also need a department ID. So let's say I work in Department 1. Sandy, my wife, works in Department 2. And let's put Taylor also in Department 2. For right now, we'll have no one in Department 3. All right. So remember that this department ID here, here, and here, that's the foreign key that maps into the departments table. All right, so that 1 is this 1, that 2 is this 2, and there's no one in Department 3. So let's imagine that I come through here, and when I create this, I showed you this before, but I can also come in and say how to add a foreign key in MySQL. All right, and they'll show it right here. I don't know what this one does, but notice you say foreign key. So let's look. We've got 2 tables. We'll look at their example. All right, so field 1 is toy ID, which is the primary key, and toy, which is of our chart. So that's the ID, and that's the name of the toy. This is boy ID, so that's the name of the boy, and that's the boy's ID and the boy's name. So we alter the boys table and we add the toy ID in here from this table into this table. All right. So we're, again, boys have toys. It's not that toys have boys. All right. So we're grabbing the primary key from this and we're adding it into this table here. But then when we say this, we have to add something like this. Add constraint, we give it a name, and we say foreign key, and what we're saying in there for the foreign key is we're saying this toy ID that we're adding into here is a foreign key that references this table, and that's the name of the field. All right? Now, they go through and they're saying, oh, you should do this, you should, but what they showed in here is basically correct. So the point is, now if I come through here and I type in, for example, delete from departments where dep name equal 3. I'm asking you right now, you think that'll work? My guess would be yes. Yes, it would work, even if I've set up the foreign key relationship like I just showed you, because there's no one who works in Department 3. So that should work. Should work. All right? But if I run that same query, and I say now instead delete this, but what I want to do is I want to delete it from Department 2. This should not work. Okay, I shouldn't be able to delete Department 2 because I have employees who work in Department 2. If I allowed that to happen, if I allowed you to remove Department 2, this record from this table, I would have two records in this table that would be orphaned. In other words, they would have a department ID that does not map up to the departments table. If you allow for orphaned records, what that does is it breaks a tenet from database, which is called referential integrity, which basically says you cannot have orphan records. All right? You cannot. Now, hopefully that made sense. I threw a lot at you in a very short period of time. All right? The other thing that's in here talks about indexes. We've already talked a little bit about indexes. I'm at 20 minutes right now, so I'm going to end this lecture right now and come back with a very short little lecture on indexes in just a couple minutes.